building a humanoid robot is supposed to take nearly a decade. Somehow, dozens of Chinese companies compressed that timeline into a matter of months. Over the past year alone, their humanoid robotics companies surged past 140. By any normal industry timeline, that shouldn't be possible.
I call AI and robotics the supersonic tsunami.
If you understand how that decade got compressed, you'll understand why the entire robotics industry can suddenly explode overnight. Because we actually have seen that exact movie before. In 2010, Nokia looked absolutely untouchable. But if you were only watching the design labs, you missed the real story. Apple didn't win the smartphone war just because of Steve Jobs' brilliant vision. They won because Tim Cook spent that exact timeline quietly building an airtight, hyper-efficient component supply chain across Asia. If you ignore what was happening in Shenzhen's industrial parks back then, you missed the entire smartphone decade before it even started.
They are all buying the Pro.
Now, ask yourself this. Are you waiting to see a humanoid robot in your local grocery store before you believe this revolution is real? Because by then, you're not ahead of the curve. You're just watching the news like everyone else. Robotics is sitting at that exact same tipping point right now. Component costs are already falling, and the margins are already improving. By this time, the signal isn't coming from Silicon Valley. While Western analysts are busy debating which robot company in the US or Europe will perfect the software brain, over 60% of the key hardware components needed to build these machines at scale are already being mass-produced, standardized on the other side of the planet. But this isn't just about factory capacity, it's about an overnight explosion in market players. Why did humanoid robotics companies in China surge past 140 in just over a year? Not just flashy pitch decks, real purchase orders. There's one humanoid maker called Ubtech, locked in contracts worth close to $200 million. China's state power grid separately spent almost $1 billion buying 8,500 smart robotic units for infrastructure work, cheap labor, cheap parts. That's usually the first guess. But dig into the talent and the component data, something else shows up. It's closer to a spillover. Two industries sharing the same industrial backbone you didn't know was connected. Follow the people first. Robotaxi, self-driving taxi program, isn't just a Silicon Valley story. China actually runs some of the largest driverless taxi fleet on the planet in cities like Guangzhou. But as that industry hit regulatory delays, thousands of senior autonomous driving engineers, many from major EV and ride-hailing companies, suddenly had nowhere to go. So where did they land? Take XPeng Vice President of Autonomous Driving, one of the most senior self-driving executives in China. In April 2026, he became CTO of a humanoid robotics company. But he wasn't alone. Engineers who once worked on Waymo's self-driving project are now founding robotics companies of their own. And also, the hiring data tells the same story. Robotics job posting in this space jumped 36-fold in early 2026, with salary climbing above $8,000 a month. For context, the average Chinese salary sits around $900 a month. These engineers are earning 10 times that. Still, engineers alone don't explain a 6 to 12 month build cycle. You need the parts to move that fast too. And that's where it gets stranger. Harmonic reducers. Think of them as the most expensive component that let robot arm move precisely. Used to cost nearly $1,000 each. Now they are down to around 90. Same backbone, same moment. Different label on the door. Which raises an uncomfortable question. What if the last decade of EV and self-driving spending wasn't really about cars or taxis at all? What if it was just rehearsal? But cheap joints and expensive engineers still leave a gap. A big one. Building a robot used to take 3 to 5 years, sometimes longer. This new wave did it in 6 to 12 months. That's a 4-fold speed up. What actually broke that time barrier? The answer traces back to the end of 2025. The entire hardware platform became standardized. Platforms like NVIDIA's Jetson Thor, think of it as a ready-made robot computer, became a kind of universal motherboard, a standard one every builder could plug into. At the same time, China's supply chain turned custom motors and other robot parts into plug-and-play modules. Robot building stopped looking like building a car from scratch, where every part is custom engineered. It started looking like building a PC. Buy the processor, snap in standard components, and assemble. That single shift is why 2026 looks so sudden. And once you see it that way, everything else starts to make sense. Here's what makes sense first: the price tag. For the last decade, pioneers like Boston Dynamics built robots the hard way. Proprietary code, custom chips, Purpose-built motors, everything engineered in-house. Time-consuming and expensive. Tesla's Optimus is claimed to be priced at $20,000 to $30,000. But the industry estimates puts its actual manufacturing cost for now closer to $50,000 to $100,000. Boston Dynamics Atlas and Agility Digit run even higher, $150,000 to $250,000. China's 2026 supply chain flipped that model entirely. You buy an NVIDIA processor, snap in standardized Chinese-made graphics card, memory, and the power supplies, meaning joint modules and sensors, then load an open-source AI brain on top of it. One full bill of materials breakdown came in around $50,000, matching Tesla's low estimate, and well under half of what Atlas or Digit cost to build. And remember, this is with one build cycle, a fraction of this. And that gap isn't just economic, it's ideological. On one side, you have Figure AI and Tesla Optimus. They are doing with the robots what Apple did with the iPhone. Vertical integration and keep the whole system closed. Custom parts, custom brain, nothing borrowed. They're betting that owning the entire machine from top to bottom wins them the one robot that beats everyone else. On the other side, China's new hardware wave isn't trying to beat Tesla at its own game. Players like Agibot, backed by massive funding, are running the Android playbook instead. If you can't outcompute Tesla in the closed system, you open it up. Now, flip the camera around, because if you're watching from outside China, you're already working with a delay. Western analysts won't see these companies' real numbers until year-end earnings season. That's a month away. But early bills of materials data and the real infrastructure purchase orders, the kind coming from utilities, not press releases, already point somewhere specific. What does this mean for the robotics industry itself? Hardware may become less differentiated. This won't be a winner-take-all market, the one someone assumed. One dominant humanoid brand sweeping the whole category. It's shaping up to be hyper-fragmented. Hundreds of narrow brands all running the same NVIDIA compute platform and the same standardized Chinese components, each carving out a niche, power plant purchase, warehouse work. That said, fragmentation doesn't mean everyone survives. When the barrier to entry drops this low, the barrier to failure drops with it. Most of today's 140 companies probably won't exist in 3 years. The same price war that made this boom possible will end up thinning it out. One quick parallel worth a single sentence. This is roughly what happened to Jones once DJI commoditized the hardware. When physical shell gets cheap enough, the center of power in the industry moves somewhere else, which leaves one open question worth sitting with. If building a robot can walk and work becomes easy and cheap as assembling a desktop PC within the next 3 to 5 years, then the real competition won't be over who builds the best metal body. It will be over who controls the operating system running millions of them. The hardware advantage is becoming easier to replicate. The real fight over software and the real-world data is just getting started. Here's what I want to hear from you. A year from now, will this still be a hardware story? Or will we already be talking about which company controls the software running underneath it? If this video connected some dots for you, I've handpicked 2 more videos here. I hope you will enjoy them. Thanks for watching. I'm Justin. I will see you next week.